So at this point, Spacefighter has support for players, enemies, weapons. Soon we'll have support for power-ups as well as attachments for our ships. This is all nice, but what do we need to do to pull all of this together so that Spacefighter begins to feel like a true 2D top-down scrolling game? And that is, we need to create some sort of a level for all of these things to exist in. If you think about it, every time Logan has created something new, an asteroid, an enemy interceptor, etc., what has he done to test it out? He's simply gone into the game class and instantiated one of those particular items, and then we've watched it simply scroll onto the screen, down, and then off the screen. Of course, if we didn't destroy it first. But that doesn't really feel like a game. I mean, it's the start, if you will. But in the end, the last thing we want to do as a programmer is go into the game class and have hundreds, if not thousands, of instantiations of these different game objects and have them scroll. That just doesn't work. It doesn't make a lot of sense. So in this video, we're going to start talking about the concept of a game level. And in the next video, we'll create it. We'll see it in action. The good news is it's actually very simple. So to conceptually visualize a level, I am going to draw out this large playing area. So this we shall call a level, the entire thing. Now, of course, we're not going to see the entire level on our screen. As you can see, this is a very short level. The area in which is being darkened in right now, this is what we actually see. We could call this right here the start of the level, and we could call this the end of the level. And if we were to take this large area right here and move it down, yet keep our screen fixed, so our screen doesn't move at all. If everything moves down, it gives us the illusion of moving forward. Now, if we were to position game objects at particular points along the level, here's our little ship, and again, we simply move this level down, all of these items end up coming onto the screen. And we can fight them, we can dodge them, but it feels like we're traveling, it feels like we're moving forward through a level. And when we reach the very end of a level, if we were then to take and swap that out for another level that had some different positioning of items, maybe even some more advanced items, you would now feel as though you have advanced into a new level, maybe a more complex level. Once again, here's our screen. And you can see how we can chain these together to give the feeling of moving from level to level. Okay? So that's what we're aiming for. And if you think about it, with any 2D top-down scroller out there, everything's predictable. Let's think about Raiden for a second, one of the most popular 2D top-down scrollers around. With Raiden, you can always expect enemies to be at specific places at a specific point through the game. That's just how it works. Because of that, you can start memorizing patterns, you can start devising strategies, and you can really begin to master the game. Again, it's a scrolling type of game. So this is what we're putting together here. Now, how are we going to go about doing this? Well, let's first think about the items that are in there, because obviously we know that we're not really moving forward. In essence, we have a screen, and we're simply spawning things right off screen and letting these things scroll down. There really is nothing back here because there is no back there. Now, granted, we could have a back there. We could create items that are in the Y location at negative whatever, way off the screen, and slowly increment those to the point that at some point they become visible. But do you really want to go about doing that? If we had a level that had 5,000 items in it, do you really want to create 5,000 items that are all up here? So basically, they're sitting in memory, and then slowly over time work their way onto your screen, where at that point they become important. But before they actually make it onto your screen, they're not important. So that is one method that we could employ, right, Logan?
Yeah, and that would make the level almost literally, in the two-dimensional sense, exactly what has been drawn. The downside is, like you said, each of those would have to be an actual instance in memory, not to mention the fact that the game engine is going to be calculating each and every item as though it was completely relevant to on-screen gameplay.
Not good, not efficient, and something that we don't want to do. So like I said, everything that we've done so far has involved the spawning of, what do we use? Negative origin. It puts it right off the screen, then it simply moves down onto the screen so it looks like it smoothly scrolls in. That's the concept that we want to employ. Now, how do we give the illusion of this type of a level but using this concept? Well, all we need to do is spawn items at specific times right off the edge of the screen and let them scroll in. And if every time we replay the game, the items come in at the exact same time from the exact same location, we will have created the look and feel of a level like that. It'll look as if we are traveling through a bunch of game objects that truly do exist over a space, a distance.
So in that way, we would describe the y-axis positioning by using a time delay. The amount of time it takes before an item spawns in Y, it gives the illusion that it was farther away up the screen or farther away in Y.
Correct. So we are going to be creating a level class. The level class is going to hold a static list. This static list will be more or less a series of instructions specifying with each instruction a particular game object to be spawned at a particular time with a particular direction and a particular speed. Okay, so let's go ahead and clear this up a little bit so I can start drawing this out. So this is the first time they're learning to do something kind of like MIDI, a whole bunch of instructions that then simply play back over time.
The idea of playing through a sequence.
Yep, playing through a sequence. So it's like a sequence list that we're about to create. So to make this a little easier to visualize the data type that we're going to construct, because this will be a new data type that we're going to use, let me first just draw out a table real quick. Start with time, because we need to know at what point during the game the item needs to come to life. Let me see if I can make some halfway straight lines for you guys. That's pretty nice. So time, we're going to need to know what type. We'll need to know what position in X. We're not worried about what position in Y, because if you recall what I said just a second ago, the system that we're using involves items spawning right off screen, scrolling down onto screen. So we already know where in Y we're going to be spawning, so we don't need to record that information. Next, speed. And finally, our direction. Excellent. So that is the information that we need to store in a record. And then we need to more or less assemble a table, like in a database, and in that table store a bunch of records. Then play back through these records and spawn the items at the time given by each record. So I'm going to add one more thing that will not be in the data structure that we're going to create. I'm going to add an index. Since we know that we're going to end up with a static list that will hold these records, we know with a list that we can index items. Everything is indexed. So our very first record will always be 0. So using the struct, and the struct internally has time, type, position X, speed, and direction, let's go ahead and start creating some records and store them in this static list. So this right here is my static list. So first record, let's say at 1. So what does 1 mean? Well, with the system we're putting together, 1 means at second 1 in the game. So at 1, go ahead, Logan.
Meaning that the game time would have to progress from a beginning time of 0 up until 1.
That's right, 1 second in. We're going to, I'm just going to abbreviate everything I'm going to jot down here. We're going to create an asteroid. Where are we going to create it at? Let's create it in the center of the screen. So basically, here's what's being put together. Let's clean that up a little bit. Finish this line off. So an asteroid needs to be spawned right here 1 second after game begins. It needs to have a speed of whatever we, as the level designer, want to give it. Let's say 2. And let's say this guy's moving in a very simple direction, 0, 1. That means he's moving down, so he'll scroll onto the screen, and he's moving at a speed of 2. So when we start the game, count 1001, and all of a sudden we'll see an asteroid scroll onto the screen. So that's what we're looking for. Let's add another record in. So let's say index number 1, because we're going to have 1, 2, 3, so on and so forth, that at game time number 1, interesting, we have another asteroid who's positioned at center minus 50, who's traveling at a speed of 1, who's traveling at 0, 1. So he's also moving down. So what do we end up with now? Again, C represents the center of our screen. So in X, we've just gone negatively from the center. So we've gone over 50 pixels. And we have another asteroid that's going to start out scrolling onto the screen at the exact same time as the first asteroid. But he's traveling at half the speed. So several seconds later into the game, you may have the first asteroid down here, while the other asteroid will be back here. He's moving slower.
But one thing to point out is because their times are the same, that means they will spawn into existence at the exact same moment.
Absolutely. So let's go ahead and add another record in. So let's say a time of 3, we want an enemy to show up. And let's say that the enemy is going to be plus 100 off of the center. And let's say that he's moving at 2. And let's say that he is moving, I'll just keep everything simple here, 0 and 1. So he's moving down as well. So this means that after we have started the game, the third second after the game started, so 3 seconds in, we spawn an enemy that is 100 pixels over to the right of the center since we're going positively. So here's our enemy who's traveling at a speed of 2. Straight down, so 3 seconds in, he scrolls into existence. There he is. He spawns, he's moved on. Now, of course, he can take a life on all to himself for the simple fact that he's going to try to avoid us, and if we had any sort of AI in there, then he could start acting on his own. He's come to life. But we have spawned him in a very predictable manner. So this is all we're doing. We're simply going to come in here and create these records. So we could have another at 6 seconds in. We want maybe another asteroid. We'll have it spawn back in at the center. It's going to move kind of slow. And maybe it's going to move 1, 1. So we'll put a bit of an angle on it. So he's traveling diagonally. Okay? So very, very straightforward. Storing this information is very straightforward. We will create a struct. The struct will contain the components we've talked about here. And then each time we're going to add an item into our level, basically construct the level. This has nothing to do with playback yet. We will create a new record from our struct. We'll populate it with the information we want, and then we'll store it in that static list. So now let's start talking a little bit about the level class. The level class is going to have a handful of methods in it, so let's spend a second talking about the methods. First of all, it's going to have a build level. It's going to have an add item. Actually, you're going to find that it's going to have 2 add items. We'll talk about why in just a second. We're going to override update, and not with a D. And finally, we're going to have a spawn item. So how do all of these different methods work? First of all, at the very beginning of the game, when you launch the game, inside of our game class, we're going to make a call to build level. Build level is going to simply call on add item repeatedly to add a series of items into our static list, our sequence list of items that need to be spawned into the game. Basically, the sequence list is defining our level. So this guy is going to end up calling add item. Now, we've got 2 different overloads for add item. The point of overloading add item is so that we don't have to take direction in, for the simple fact that most of the items that we're creating are going to go down. So if you want to add an item by specifying the type, so basically we're going to say type, location, speed, direction. That's the information add item needs. But since often, actually, let me just circle these guys. Often our direction's just going to be down. Logan's going to create an overload of add item that won't take in direction so that we don't have to continuously do 0, 1 over and over and over. So it's just going to save a little bit of typing there. But I want you guys to understand why we're putting it into play. So calling on add item, we call add item for every single item we want to add into the list. So with the example that we've put together right here, we've called add item 1, 2, 3, 4 times to give those items, make those items into the list. And then from there, the level's been constructed. Now, back in the game class, we're going to call, in the game class's update, we're going to call our update over here in the level class. This guy is simply going to, in turn, call spawn item every time an item comes up for spawn time. All right, what do I mean by that? And how is this going to happen? Well, basically, we know that update's going to get called every game tick. We also know that through game time dot total seconds, we can find out how long an XNA game has been running. And total seconds, that tells us in seconds. This number right here, these numbers are in seconds, okay? So what we can do inside of update, we can basically have an index pointer, if you will. Just a variable that allows us to start out pointing right here at the first item. So we're pointing at this guy. We're going to actually call him item index, I do believe. And starting at him, we're going to take a look at our total game time that we've been running. And anybody that's equal to that or less, we're going to spawn. Okay, so we start out, we're at 0 seconds or maybe a tenth of a second in. Well, at the moment, we're just simply going to sit there because we can't spawn anything yet. Or, yeah, we've got to get all the way up to or greater than this guy right here. Let me make sure this isn't confusing. So once we hit the game time of 1 second, then we can advance. So in this particular case, we would hit 1 second. So update gets called. We see that our game time is 1 second. So it's like, good, spawn them. So this is going to call spawn item for this record. That guy gets created based off the information that's stored in that record. We increment, so we're in a loop. We increment our index so that we're now pointing at the next item that's being stored in this list, and we check its time. All right? Is this equal to our current time or before, meaning it needs to be spawned by this point? And the answer is yes, it's equal. So he gets spawned with another call down to spawn item, and then we increment once again. So we're pointing right here. We check this guy. Is this guy equal to our current time or before? No. He's a time in the future, so he doesn't need to be spawned yet. So that's it. We simply break out of the loop, and we're done. The next time we come back in to our update, which is going to be the very next tick, we haven't really advanced much in forward in time, so we're just going to sit there. We're not going to advance. We'll break out of the loop immediately. But when we hit 3 seconds, or let's say that the way the game tick fell, we're actually 3.01 seconds, so we're just a little bit ahead of 3 seconds. So we come in here. Again, our total time elapsed is 3.01 seconds. We take a look. Is this number equal to or less than? Yep, it sure is. This guy needs to be spawned. So we make a call down to spawn item using this information. That guy gets spawned into existence based off his record. We advance forward, then we check. All right, what about this guy? This guy's in the future. We're done. We break out of the loop. So that's how the whole thing basically runs. Every time our game update runs, we come into the level update, and we simply check the current record that we're pointing at with our item index. We check its time. Is it time to spawn? Should he already have been spawned or spawn right now? If the answer is yes, we spawn him and advance forward so that we're looking at the next record. We continue doing that until we get to a record that has a time greater than our current total seconds in which the game has been running. And then we say, all right, well, we got to wait because that's in the future.
And one more thing I want to point out is the specific function of item index is to remember where we are in this item list.
That's right.
because if we were to always go back to the very beginning of time and spawn every item up to that time, that means that in every game tick we would continuously respawn the original items. So what happens is, along with every call to spawn item, we also increment that item index counter. That advances our position into the list, so that next iteration through the list we simply start at our last known place instead of starting from the beginning. That way old items don't continuously spawn as the level progresses.
That's right. Now, this is going to be a very simple implementation of this idea. You'll notice that we are working with game times total seconds, so rewinding back in time or jumping forward can be a little tricky. Very little modification is required to the class Logan is about to put together. You guys have already been armed with every bit of knowledge that you need to make the modification so that you can scroll forwards and backwards through time, which could be very helpful if your level items list contains 500 seconds or maybe 10,000 seconds worth of items being distributed. You don't want to play through 10,000 seconds to see how something feels later in the level. So what if you wanted to quickly jump to a particular spot? Or what if you wanted to rewind something with, maybe you want to bind one of your keys on your controller to jump back 5 seconds. Very simple modifications can be applied to this level so that you can do that. I just want to point that out so that when you guys see Logan using GameTime.TotalSeconds, you start thinking about, can I use a variable? Can I use some offsets? Can I use simple addition and subtraction to make this so that I can jump forwards and backwards at will? The answer is yes, it's very easy. So I want you guys to think about how you could go about applying some logic to that particular problem. But again, this is the first time in the XNA class in which we've created a true level. I mean, back in Precision, you could say that a level was nothing more than a handful of enemies, and once all of those enemies were dead, we advanced. This is a little more advanced. We have a start and we have an end, and as the player, it's your responsibility to get from the start to the end. And in essence, all we're doing is we are playing a recording back, if you want to look at it that way. And once we reach the end of the tape, we've reached the end of the level. And the neat thing is, as I drew all the way back here at the beginning of this video, we can come up with different lists if you want to represent different levels. You could have first of all, you could come up with a system where this information is stored out to a text file. Let's go with something super simple. So you have a text file, you read all of this information in, now you have your level. Now you reach the end of the level, you could have a loading screen, you could grab another text file, read all of that information in, and now you have another level. And you could start linking your levels together that way. You could have one file, and inside that one file, you could have a specific header that says this that follows is level 1. Then further down, this that follows is level 2. I mean, it really comes down to you and the format that you would like to use. In our particular case, we're demonstrating the construction of an engine. We're not concerning ourselves with I/O and wanting to externally save this information, but it's very easy to figure out how to do it. You could even use an XML file for handling all of this, and C# comes with some fantastic built-in functionality with .NET that you can use for reading that information in. It's all at your fingertips, but just keep in mind the concept that you're seeing is the recording of basically spawn instructions. That's it. So it's a list full of spawn instructions, and they are executed when their time comes up. Is there anything you'd like to add to that, Logan?
No, I think that sums it up really nicely. Again, just a quick review is that we wish to give the illusion of a field of enemies which we can progress through. And we would like that field of enemies to be, well, arbitrarily large. That means we'll use this recorded list, because think about it, that recorded list isn't itself updated continuously. We can have a rather large amount of items in that list and not impact gameplay. So instead, we simply play that list back item by item, and as items, exactly just like you said, as their time comes up for spawning, they are spawned into the level, and we advance into the list. And in that manner, we literally just play this list back over time, and that results in timed spawning of game items on the screen.
And it's really going to be simple, the way in which we're going to go about calling add item. We're going to create a variable that we can work with called time cursor.
And really this time cursor is just a little helper to keep track of what the current time is. Because, of course, the records don't really care about this cursor. They have a very specific time. They happen at X seconds, and that's what the level engine is concerned with. But as far as ourselves now as a level designer, it would be nice if we could, looking at, imagine a large list of instructions that comprise your level. What if you wanted to copy a small segment of it and simply bump it down so it took more time to reach that part? Or you wanted to take that segment and completely duplicate it so that the player would have to play through 2 volleys of enemies instead of just 1. What time cursor is going to allow us to do is to set up an alternate to setting the absolute value of time with every single add instruction. What time cursor is going to do is just that. It will track a current time, and add item will simply be aware of the time cursor and save that value into the current item at the time that add item is called.
So what I wanted to demonstrate real quick is, let's say that time cursor is initialized to 0. This right here, pretend that add item line is duplicated one more time down here. This right here would be the start of records 1 and 2, or index 0 and 1's records, if you will. And then we would need to simply set our time cursor ahead again. So right now we've said plus equal 1. That took us to 1. So we could say time cursor, I'll just put TC, plus equals 2 to push us ahead to 3. And then we could turn around with another add item. And now we've just put this record in here. But here's the key thing that Logan was just saying a second ago. Notice how we've used plus equal instead of explicitly going in there and saying at second 1, add these things. Later on, if Logan wants to shift everything, he can easily do that. We can come back right here and say time cursor equals 5. That means we're not going to start our first item until second 6. So this would actually be a 6 right here. And this would be a 6. Everything would be adjusted accordingly. 5 would be added to everything. So by using plus equals with our time cursor, we can very easily shift the time back and forth. And we could even go in here and add a time cursor equals and give it a very explicit number and push everything from this point forward. Offset it, basically. And that's really nice. So that's one of the ways that we're going to make sure all of our records get added is by following this plus equals mentality so that we can easily offset the times. I just thought I'd throw that in there real quick.
It also makes the level creation instructions easier to read. If you simply read the instructions top to bottom, you can just look at the time that you're currently at. You see, okay, something happens. 2 seconds later, something else happens. Yeah. Once again, it makes it even easier to explain the table that's drawn up where you have the times of the 2 asteroids at time 1, then an enemy at 3. The idea that there's a 2-second delay in there is easier to represent where you see, all right, asteroid, 2 seconds, enemy. It's like, 2-second delay. Here it's like, okay, well, 3 minus 1 and do math, and then, okay, well, there's a 2-second delay in there.
Mm-hmm. So again, it's a simple system, but it's very effective for us. It's also very efficient as well in the fact that we're not spawning hundreds of items that are just sitting out in memory waiting for their time to finally make an appearance on screen. So with that, that's going to bring this video to a close, and in the next video, Logan's going to put together the level class. Thanks a lot, everyone.